Good morning. I am Dr. Ramesh Visvanathan, a chemistry uh, IB uh, coordinator, and I'm a part of SEB 7N curriculum. And today my topic is acid deposition, that is topic 8.5. How acid deposition actually uh, takes care of and spoils the environment, and how what pollution can affect the environment and so on. So I'm going to be talking about that briefly. This is a short video, and how what are the consequences of acid deposition, how we need to prevent it. So you can see this is an archaeological statue, and it is got and disfigured by the acid rain. So this is one of the effects of acid rain, it is acid deposition. We go on to the next slide, where you can see I have indicated the pH scale. What is acid? Neutral pH is pH 6.8 to 7, and the acidity is anything less than 7, that is pH 7 to 1. And as you can see in the slide that I have actually put in day-to-day uh, items which we use in our home. That is lemon juice is pH 2, wine is pH 4, rain is pH 5.5, and human blood pH is 7.5. Baking soda is pH 8.5. Detergent or soap is pH 10, and bleach is pH 12.5. And as you can see, the optimal range for most life is pH 6.5 to 8.3. So anything less than 6.5, anything greater than 8.5 is, at least to the human and the environment, is not acceptable. I have put the same slide there in the sense the pH range. Here the neutral pH is 7, and as you can see, the topmost is battery acid is pH 1, lemon juice is pH 2, vinegar is pH 3, and as you can see I've bucketed acid rain, and the acid rain is bucketed between 1 to 5, wherein adult fish die in this region, fish reproduction gets altered, and you can see between 5 and 7 is the milk, where normal range of precipitation pH of milk is 5 to 6. The normal range of stream pH is 6 to 8. Baking soda and seawater is 8 to 9. Milk of magnesia is 10 to 11. And ammonia is 12 and lye is 13. So acid rain is naturally slightly acidic, but is pH 5.6. It is caused by carbon dioxide emission in the air, and carbon dioxide in the air is dissolved in the water, that is rainwater, forming carbonic acid. And as the rain comes down, it smells disaster to the environment, the land, sea, and the buildings, the infrastructure, and so on. So what does the carbon dioxide or the uh, source of uh, emission, what does it, how does it happen, and what are those? I've given a YouTube link. You can actually Google the YouTube link to understand how acid rain and acid deposition takes place. When sulfur and nitrogen oxide dissolve in the rain, they form sulfuric nitric acid and can have a very low pH in pH 1 and 3 in this pH scale. pH scale is logarithmic. pH 1 is 10 into 10 more acidic than pH 2, and 800 stronger than pH 3. You can actually see that sulfur and nitrogen oxides are two primary causes for acid rain. So this slide deck is a very nice representation of how acid deposition and the process of acid deposition happens. So because of industrialization and vehicular traffic, we have the acid gases, that is the nitrogen oxides, that is nitrogen dioxide, nitrogen oxide, and sulfur dioxide, which are emitted and released into the atmosphere because of industrial gases, vehicle traffic, and so on. So these gases are carried by the wind and deposit themselves in the clouds. And when it rains, normally these gases, which are dissolved in the rainwater, come down to the earth to form acid rain. And when it comes down, the acid rain kills plant life, pollutes rivers, streams, and erodes stonework. When I say stonework, the architecture, buildings, etc. So this is a kind of a flow diagram which is circular in nature, and this is how acid deposition process happens. Chemistry of acidified precipitation. Acid deposition can be either wet or dry. Wet deposition means acid rain, snow, or other precipitation. Dry deposition, acid gases or dry particles not mixed with water. So you can have dry deposition of dry particles coming in from the atmosphere, getting into the land and polluting the land. Pollutants can be classified as either primary or secondary. Primary pollutants are those directly emitted by a factory or automobile. Sulfur dioxide, nitrogen oxide, and nitrogen dioxide, usually represented as NOx. So you can understand in New Delhi, which is the capital of India, every year between October to February, you find the air is completely clogged. People cannot breathe freely, and this is because of vehicular traffic, pollution, stubble burning, and all this goes to the atmosphere, and then the atmosphere gets clogged, and people are unable to breathe fresh air. So for day-to-day living, people have to breathe fresh air, and the pollution is a very severe cause in the world. And you can understand that because of pollution and because of not treating the environment properly, you can have climate change. So climate change is a world phenomenon. Entire world is talking about climate change. United Nations is talking about climate change and how climate can damage the environment. You can see I have in the bottom portion of the slide deck, I have indicated the types of sources from where these sulfur dioxide and nitrogen oxide emissions are coming from. That is utilities, transport, industrial, manufacturing process, industrial combustion, and other types of sources. You can you can understand that nitrogen oxide NOx is a major part from transportation. Sulfur dioxide is from the utilities. So you can have clubbed both. This is the emission by source. So this is a major cause of concern to all the countries, and some countries have taken measures, and we have to take measures, and I'll tell you what are the measures which we need to take. Secondary pollutants. Primary pollutants are sulfur dioxide and nitrogen oxide. Secondary pollutants are primary pollutants react with other substances in the atmosphere and create different pollutants. That is hydrogen H2SO3, that is sulfurous acid, H2SO4, that is sulfuric acid, and nitric acid, that is the sulfur dioxide reacts with the water and forms sulfurous acid and sulfuric acid. So does nitrogen dioxide react with water in the atmosphere to form nitric acid. So these two primary secondary pollutants need to be controlled to stop the acid rain. Effect of acid deposition on the environment. Direct effect. They inhibit embryonic development of fish. Chlorophyll loss and yellowing of trees and buds diminish the growth of trees. So you can well imagine when there is a chlorophyll loss, the plant is not able to emanate oxygen. And if you are not emanating oxygen from the plant, which is the primary source of providing oxygen to the atmosphere, you can well imagine how the atmosphere will be depleted with oxygen and we will be suffering with breathing issues. Thinning of cuticles, wax coating on leaves, symbiotic root microbes kill, that is rhizobium species and other beneficial fungi. So all this will take an impact. So you can see here, this slide talks about direct effects. I've already indicated inhibits the embryonic development of fish, chlorophyll loss and yellowing of trees, symbiotic root microbes kill, and other beneficial fungi. Effects of acid deposition on the environment. They have toxic effect. Aluminium leaches out of the soil into the streams. Aluminium disrupts salt, water, and oxygen, regulating mechanism in the fish. Aluminium can also adhere to fish gills, causing suffocation. Lichens sensitive to sulfur dioxide gases and used as indicator species. So you can also have acid deposition on the environment where the nutrient gets affected. So how does it get affected? Soil particles cannot retain calcium, magnesium, potassium, and other nutrients in the acidic environment. So these nutrients are leached out of the soil or not available to the trees. So the primary source is the tree, farming, etc. So in case if the nutrient effects are depleted in the soil, we will not be able to get our food. The farmers will not be able to concentrate and get the food across to human beings. So dissolved aluminum ions damage root hairs, the smallest roots, which are the most effective at absorbing nutrients. So the trees are unable to absorb as many nutrients. So it's important to have the nutrient balance in the trees. And nitrogen fixing bacteria don't function as well. So nitrogen have to be added to the soil nitrates. So you can understand the effect acid deposition can have on the environment, especially the nutrition which are there in the part of the soil. And another slide deck is the damage to human infrastructure. Acid rain dissolves limestone structures, especially buildings and structures. So all the archaeological buildings across, you can see in India, very many buildings get damaged with acid rain. So we need to preserve our architectural uh, areas. So it is very important that we understand how to control the acid deposition. So acid deposition, somebody says it is regional, somebody says it is global. According to me, it is regional specific to a country and it's also a global phenomenon. Acid precipitation falls back to Earth rather than entering into the stratospheric stream. It is very important to control acid precipitation. Most areas are downwind of pollution sources. Canadian forests damaged by coal-fired power plants in USA, Scandinavian and German forests damaged by British coal plants. And as you see every year, year after year, you find that the uh, earth, especially in Australia and in California, are ravaged by fires. The next slide deck talks about the globe in large. So the green bar talks about potential problem areas because of sensitive soils. The yellow bar talks about potential problem areas because of air pollution, emissions, and acid deposition. The red bar talks about traffic problem areas, including lakes and rivers. So you can see the entire globe is gets affected, and we need to take care of our environment. Reducing the effects of acid deposition. How do you do and how do you reduce it? So these are the following techniques. You can actually do the liming of lakes to neutralize acidity due to acid deposition. You can do pre-combustion before burning techniques which are used so that no gases are sent into the atmosphere. End of pipe measures is after pipe burning. And of course, we can always reduce our use of fossil fuels to help solve this problem. Nuclear powered and electric cars, you can see the world is transitioning to nuclear powered electric cars because the main source of pollution from the cars and from automobiles is sulfur dioxide and carbon dioxide and nitrogen oxide and nitrogen dioxide. So how do you do pollution management strategies for acid deposition? You can actually, number one, you can replace by switch to renewable energy sources, that is reduce fossil fuel use, increase energy efficiency, better light bulbs and appliances, more public transportation, fewer automobiles on the road, use low sodium fuels, low sulfur fuels, and regulate, install scrubbers or smokestacks of coal-fired power plants to remove sulfur dioxide, catalytic converter installed on automobiles required by law in US, Canada, and Europe. So we can replace, regulate, and we can restore by adding limestone to acidified lakes and streams, using limestone or calcium carbonate and neutralized buffer the impact of acids, freshwater ecosystems, and much more vulnerable, expensive, and hard to determine how much to add. This slide that I have actually given the strategy for reducing pollution in one column, example of action in the next column, evaluation, how does it evaluate. So I will just go through one of the points where altering the human activity reducing pollution. So what are the examples? How do you do it? Replace fossil fuel by using alternative ethanol to run cars, renewable energy sources for electricity, reduce overall demand for electricity, education campaigns in population to turn lights off, insulate houses, etc. Use less private transport, carpooling, public transport, walking and cycling. Number of countries have resorted to using cycling. In Delhi, you have the government doing alternative registration number cars running on a particular day to ensure that the vehicular traffic is reduced. By reducing vehicle traffic, you can reduce pollution. So you can see how the strategy for reducing pollutions, example of action and evaluation is done by the countries, the people who are in charge of these particular states and countries, what can be done to ensure that reducing pollution and what the examples which are given. Acid deposition finally is very serious. Remember, this is not a global problem but a regional one, most serious in the sense the phenomena is global, but there would be specific problems specific to a country, so we need to address those issues. Mountain top forests, so the possibility of fire ravaging, etc., happens on the mountain top forests. Areas with high auto traffic, so you can well imagine countries with high population of traffic, auto traffic can be part of this acid deposition, and we need to control, and it is very serious. And areas downwind from industrial centers, so you can imagine if you have area which is part of the industrial management, you need to shift this area, and very many countries are doing that to ensure that the pollution does not happen. And more important, lastly, is we need to create an impact of pollution management strategies. This impact and strategy need to be publicized, be told worldwide, and so in America, the President-elect Joe Biden has nominated a person to take care of the climate management, climate change, to take care of the pollution, the environment, etc. So this is a step initiative, and he's going to be part of the United Nations. The entire United Nations is understanding, trying to put up a procedure how to stop the climate change, how to understand the vehicular traffic, how to understand the pollution. So this is an extremely critical step in ensuring that the place where we stay are safe and the land, the rivers, seas, etc. are controlled. Thank you very much for your attention.